5 cycles. Okay, so the customer order cycle, replacement cycle, and manufacturing cycle, and the procurement. That is the way how the industries or the manufacturing plants procure the material. Okay, so this is called as a cycle view. And the next one is called as the push pull view of supply chain. So the many industries, the multinational companies, they practice this push and pull view of practices. So I elaborate what do you mean by push processes. So the here the manufacturing takes place in anticipation of the demand. That is, so they estimate the demand in the market, and they hello. Madam, it's audible now. Okay. The processes based on the anticipation of the demand, and the pull process are nothing but based on the actual demand. I'll give an example of the Dell. Okay, the Dell collects the orders from the whole world. Okay, and they classify the how much varieties, what specifications, and then they keep some of the components be ready irrespective of the variety and all. They guess the anticipate the demand in the market, and they keep ready, and the final assembly based on the customer specification, the products will be assembled based on the actual demand. That is called as the pull process. Okay, the push processes are based on the anticipation. Like this, the many industries will club whether to what stage they need to have a push processes, and to what extent they have to pull processes. So the push pull, the supply chain practices are going to be usually adopted by many industries nowadays. So this already I discussed about the Dell. Then the other important topic in the supply chain is strategic fit. Okay, so in this, as I told you that the market demand is highly uncertain. Sometimes some people for the some product the demand is certain. Okay, then how the business manager have to play a game in between certainty and uncertainty of the demand in the market. And also we have two types of supply chains. One is known as efficient supply chain and responsive supply chain. That is called as the responsive spectrum. Okay. So when to adopt the efficient supply chain and when to adopt this responsive supply chain. Okay. When the demand is certain. Okay, the some of the products the demand is definitely they'll be knowing. Okay, so for that they adopt the push kind of process system where they keep ready all the products. Okay, because they know that there is a definitely there will be demand for their product in the market. So at that time they need to have more economy in their manufacturing practices and as well as in the distribution. That is called as efficient supply chain because of the guaranteed demand in the market. But when the market is so uncertain, okay, some of the products the market is highly uncertain. At that time, we cannot design or adopt the push system. We need to adopt the pull system. That is nothing but the responsive supply chain. When there is a demand, and we need to manufacture and produce goods and distribute to the customers. And nowadays the customers are also not willing to wait for much times as earlier the customer used to wait. Okay, so if you go down around the 20 years back, 2 decades back, so if you want to book a car, so we need to book the car for 6 months in advance. So the car usually comes after 6 months or after 1 year. So nowadays the situation is not like that. The customer he wants so and so model, so and so model, and so variety. So they are all available in the market. Okay, so that is called as a responsive supply chain. Okay, so how to responsive supply chain, and the strategic fit is called the zone of strategic fit, which has been shown in the sketch. Okay, the marketing manager, the supply chain manager, we need to set our see our demand, and we need to decide whether we need to design efficient supply chain or responsive supply chain. Okay, then we need to understand the customer and the supply chain uncertainty and understanding our supply chain, and then we need to achieve the strategic fit. Again, there are four drivers called as facilities, inventory decisions, transportation decisions, information decisions, sourcing decisions, and pricing decisions are these drivers will affect the performance of the efficiency of the supply chain. Okay, how we make decisions, okay, the better decisions definitely will improve the supply chain performance. Okay, so this all I told about supply chain. Now I want to talk about lean manufacturing. Okay, the most of the industries, the multinational companies or the world class 500 fortune companies, they are not alone using only six sigma practices. Along with the lean and six sigma practices they are using in supply chain. That's why in this context I will briefly tell about what is lean manufacturing. Okay, the lean manufacturing is the production of the goods using less of everything. That is, human effort should be used less manufacturing space, less investment, less engineering time. Okay, and it is the business initiative to reduce the waste, okay, to reduce the waste in the supply chain or in the manufactured products. And companies are thinking and practicing green supply chain and reverse logistics in this context. Okay, because now we are bothered about environment also. The all industries industrialization spoiling the environment. How to save, how to protect our environment, that is called as green practices. That is, we call it as green supply chain and reverse logistic practices. And lean is one of the latest management tool in the cost reduction. So they reduce the cost by improving the labor usage, decreasing the inventories, reducing the manufacturing order to the shipment cycle, increasing the capacities without substantial investment in the equipments or machineries. Okay, what is waste then? Waste is anything other than the minimum amount of equipment, materials, parts, space, workers' time, which are absolutely essential to add value to the product. Okay, this was told by the Toyota, the president of Toyota. And just in time seeks to reduce the waste. The waste is viewed as a symptom of some of the unsolved problem. Okay, the types of waste includes overproduction, waiting time, unnecessary movement, inventory, product defects, process waste, rework. These are all the types of waste. Okay, that's about lean. Then I want to talk about quality and Six Sigma. The quality is being defined by Joseph Giron. He's called a quality guru. He defined the quality as fitness for use. Okay? And other definitions of quality, the to do a right thing at the right time, to do the right thing at the right time, conformance to the standard, conformance to the specification, blah blah. Okay, so there are different varieties of definitions for quality, and I want to talk about quality evolution now. The early 1900s, we used to call it as inspection, and during 1940, statistical sampling. It is being used by many of the quality gurus. They use statistics in measuring the quality. Then in 1960s, the organizational quality focus was given. So till 1960, the old concept of quality was inspect quality after production. And in 1990 and beyond, it is customer driven quality. The quality concept was changed, build the quality into the process, and identify and correct the causes of quality problem. Okay. The Shewhart, who was a statistician at Bell Labs during 1920s and 30s, he created a foundation for statistical process control. The statistical concepts are the backbone for this quality and Six Sigma. Statistical concepts are the backbone for this Six Sigma process. And this Shewhart, okay, is a statistical professor. Okay, and is called as the grandfather of quality control. And Edward Deming is called as a father of quality control. Okay, he's also a statistics professor at New York University in 1940s. Okay, so he on the name of Deming they are the quality gurus. So these two, Shivart and the Edward Deming, they are the two foundation stones for the quality. They are the foundation stones for the quality. So because of them, we are here today. Okay, and in the name of Edward Deming, a Deming Prize will be awarded every year in the country as well as at the international level. So the Union of Japanese Scientists and Engineers has announced the 2019 Deming Prize winners. Okay, the five companies were awarded the Deming Prize this year. That is LG Equipments Limited India, Shiroki Corporation Japan, Siemens Renewable Power India, JSW Steels India, L&T India. So the Indian companies receiving four of the five awards is not as surprising as some may think. The Indian companies receiving four or five awards is not as surprising as you may think. And since 2000, the organization based in India have received the most Deming prizes. Okay, and Japan is in second place, and Thailand is in the third place. The distribution of these winning organizations since 2000, okay, including the prizes of 2019 Deming Award. India has won 32 Deming Awards, Japan 20, Thailand 12, China. So see the how the Indian industries are bothered about the quality. And there are many other quality gurus. Okay, the Shivat, Edwards, Juran, Figambam, Crosby, Yoshikiwa, Taguchi. They are the quality pillars. They are the quality pillars. See, the Deming and Shivat, they are the foundation stones. The remaining contributors for the quality, they are the quality pillars. Okay, so I don't want to discuss much about this. I think you might have been already undergone about these quality pillars and the evolution of quality inspection to quality control to quality assurance, then TQM, then we are at Six Sigma now. Six Sigma are the set of techniques and tools for the process improvement, and it was developed by Motorola in 1986. 1986. That is when I completed my engineering. The Sir Bill Smith is called as the father of Six Sigma, introduced this quality improvement methodology at Motorola, USA. The Six Sigma is now an enormous brand in the world of corporate development. And in 1920, the word Sigma, yes, has been used by the mathematicians and engineers as a symbol for the unit of measurement in product quality variation. In mid 1980s, ACs, the engineers in Motorola in USA used Six Sigma as an informal name for its in-house initiative for reducing the defects in the production processes because it represents a suitably high level quality. And late 1980s, the Motorola expanded the Six Sigma methods to the critical business processes for the performance improvement. And in 1991, Motorola certified its first black belt Six Sigma experts, which indicates the beginning of the formalization of the accreditation training of Six Sigma methods. Okay, I discuss about all these black belts and green belts and champions, other things in the next slides. In 1995, Six Sigma became well known as after Mr. Jack Weck made the central focus of his business strategy at General Electric, an American multinational company which is in the New York. By the year 2000, the Six Sigma was effectively established as an industry, its own right involving the training, consultancy, and implementation of Six Sigma methodology. Then, what is Six Sigma? The term used in statistics to represent the standard deviation as the indicator of variation in a set of processes. The sigma is a Greek letter representing the standard deviation of the population of the data. What is defect? Defect is defined as any process or the output that does not meet the customer specification, customer requirement. It is called defect. Okay. Then the Sir Bill Smith is a father of Six Sigma. So we should remember all these quality gurus. Okay. So always we need to, as engineers, okay, we should know each and every guru, their contribution to the quality of the products. Okay. And almost one more thing, almost all quality gurus, they lived for nearly 100 years. Oh, it's very surprising. Okay, you adopt certain quality practices in your life, definitely will also going to live for 100 years. Okay, so what is Six Sigma? A statistical concept that measures a process in terms of defects. The Six Sigma level, that is 3.4 defects, are permitted in a million opportunities provided. A philosophy or a goal as a perfect as practically possible, and the methodology and the symbol of quality. Six Sigma evolved into the rich set of different standardized methods, tools, best practices. Six Sigma started as a problem solving approach to reduce the variation in the product and manufacturing environment. Six Sigma is a concept of improving the quality by reducing the process variations and making the continuous improvements, reducing the defect rates and improving the processes. And Six Sigma has been labeled as a metric, methodology, now a management system. And also I discussed about this. And why Six Sigma? Six Sigma saves money, that is improves the profit of the organization, improves the quality, and increases the customer satisfaction, customer trust, and the competitive, we can give the competitive advantage in the business. We can compete along with multinational competitions, multinational competition. That is a product competitive advantage. If our company named as a Six Sigma, okay, the whole world trust on the practices used in the manufacturing industry. Okay, the Six Sigma will don't come simply. We need to sweat our blood. Then only we get the Six Sigma certification and Six Sigma brand for the company. At the end, I will display the Six Sigma companies in the world. Okay, so the growth takes place, the employee pride. These are all the benefits out of Six Sigma practices in the industry. Six Sigma is about the practices that help you to eliminate defects and always deliver products and services to meet the customer specification. The cost of poor quality. What is the cost of scrap? What is the cost of rework? What is the cost of excessive cycle times, delays? So these contributes to the poor quality. Okay. What is the cost of the business lost because of the customer dissatisfaction? Product services. What cost of opportunity lost because we do not have time to supply? So the opportunity costs. These contribute to the quality. And we call it as CTQs, critical to the quality. The elements of the process that significantly affect the output of the process. They are called as the CTQs. Identify these elements and figure out how to make improvement that can dramatically reduce the cost and enhance the quality. It is an important parameter in the Six Sigma implementation. The statistical quality control is being used in the Six Sigma, and I told you that statistical quality control is a backbone for the Six Sigma. We should be very strong at the statistics, mean, mode, mediation, standard deviation, Six Sigma, CP, CPK, all concepts of statistical quality control, hypothesis testing, design of experiments. We are very strong at the statistical quality control to implement the Six Sigma. The methodological approach, the Six Sigma is a methodical approach. We apply DMAC and DMAT-V methods in the Six Sigma. The fact and data-based approach, okay? It is not the guess approach, okay? We need to collect the facts at the shop floor, okay? And the data, okay? So that's why it's called as the fact and data-based. And it is a project-based and the objective-based. Okay, we need to identify projects, Six Sigma projects in the company, and we need to target at each project to improve the process of the business. And it is an objective phase focus. That is, we need to decide objectives for training our faculty. It's an objective based methodology. The customer focus is a fundamental to the Six Sigma approach. Okay, we need to first customer is the king now. There are however, the earlier scenario, sound or the customer focus. Okay, the customers are the king. So what customer is expecting, we need to design our products. We need to add our features, what the features the customer is expecting, and deliver that product to the customer. That's why the customer focus and team approach. Okay, one man cannot do anything in the company, so it's a teamwork. Okay, the Six Sigma tells that we should all work together. The overall business improvement. Okay, definitely the Six Sigma cannot be applied in a single shot on the whole supply chain. We need to identify the process wise, we need to apply the Six Sigma, and one or the other day, whole business is going to be streamlined and we can attain the quality and reduce the cost, improve the cycle time, increase the customer satisfaction. Discussed already, you might have been went through this normal distribution curve, and also I think you went through Six Sigma level. Okay, when we are at the Sigma level 2 or 3, okay, the improvement is needed. That indicates the improvement is needed. Okay, when we are at 3.5 level, we are at the good. Okay, that is 97.7 percentage. That is the defects per million opportunities will be 22,700. So when we are at 4 to 6, that is at 6, that is 19.9997 percentage. That is 3.4 defects per million opportunities. ಒಂದು ಅರ್ಧ ತಾಸು ಸ್ಟಾಪ್ ಮಾಡೋಣ ಅಲ್ಲಿ ತಳಗೋಗಿ. Okay, these are all the things you already have been undergone. Okay, this table specifies which is good and which is bad, and DPM you already know. And the methodology, DMAC and DMAT-V. Okay, these are the two methodologies being used. So the DMAC is being used for the projects for improving the existing business processes. Already the business has been established since 10 years or 15 years, 20 years. So we need to improve our business processes, apply DMAC methodology. DMAT-V. So it is being used for the projects aimed for creating new products or the new process design. When you want to establish a new product or when you establish the new process, At that time, we need to use this DMAT-V principle. So DMAT tells you about define, measure, analyze, improve, and control. I don't want to take you much of your time on this because yesterday and previous day, I think you might have been undergone all these things and all this uh, implementation of DMAC methodology. Okay, the first one is the define. Okay, we need to define the problem and we need to define our objectives, project objectives, and taking into consideration the customer voice and measure the key aspect of the current process and collect the relevant data because it is a fact based. Okay, the measurement is to be done. Then after collecting the data, okay, we need to sit on the table. We need to invite all the people responsible for the process. We need to involve everybody in the industry. Okay, one man cannot analyze and take the decisions. Take the people who are involved, okay, in the process. Invite everybody and analyze the data and investigate and verify what are the causes, what are the problems, what are the issues, why they are occurring, what is the effect on the relationship. Okay, we need to identify all those things and determine what relationship they are being establishing and attempt to ensure that these factors have been considered and seek out the root cause what making this defect to occur, identify that. That is called the root cause of the defect under investigation. Okay, then improve and optimize the current processes. Okay, based on the data analysis techniques. Okay, provide some of the tools and techniques, okay, that I will highlighting in the next slides, and improve the process and see that they have to be controlled. The future state, what we improved method has to be practiced. It cannot be neglected because the swing back may takes place to follow the old system. No, okay, it has to be controlled. Okay, for the future state of process, for the improvement process. Product, new product to be met. What are the new product expectation demand we of the customers, measures and CTQs, product capabilities, the product process capabilities for the new process, analyze them, design alternatives, develop alternatives, and design and improved alternatives. Select the design and approved alternative best suited for the new product, and verify the selected design, and carry out some pilot studies, production processes, then hand over it to the process owner. Okay, these are the two methodologies of Six Sigma, and these are the tools. Okay, I think the tomorrow the some of the resource person will be discussing on these tools. We are using the process map. The process map illustrates the description of how the process is to be carried out. The design of experiments. It is a structured, organized method of determining the relationship between the factors affecting the process and output of the process. Then XY matrix. The purpose of using XY matrix is to study and understand the relationship between what you are putting into the process and what your customers are getting out of it, called as XY matrix. It is used to identify the gaps and areas for improvements. And measurement system analysis, the goal is to ensure that our measurement system is statistically confident, statistically reliable, statistically accurate. Then only get the correct data. And the process capability tool measures the process being able to meet the specification requirements and fulfill the customer CTQs. And hypothesis testing, investigate the theory about the suspected cause of the particular effect in the process to determine it is correct, if it is correct. And failure mode effect analysis, FMEA, is a systematic proactive method for evaluating the process to identify where and how it might fail and to assess the relative impact of different failures in order to identify the parts and the processes that are most need need of change. The effects, the ways that these failures can lead, the waste, defects, harmful outcome for the customers in future. So it is a proactive method. Before the product is being released to the market or to the customer hand, we need to conduct this FMEA analysis for the product designed or the product, and we must see that our product must be failure free, so we can satisfactorily perform in the customer hand. This is most important, FMEA. And the control plan, okay, we need to record all the improvements what you have done. Then key roles of the Six Sigma, okay, the executive leadership, the CEOs, and the key top management team members. They are the responsible for setting up a vision for the Six Sigma implementation. Okay, as I told in the earlier that it has to come from the top. All these strategies how to be implemented from the top. The top people have to change first, not at the bottom level. Okay, so the champions are the responsible for the Six Sigma implementation across the organizations in an integrated manner. The champions are also act as a mentor to the black belts. Okay, then master black belts identified by the champions and acts as in-house expert to coach for the organizations on the Six Sigma. They devote their 100% of their time in the Six Sigma. They are called as master black belts. Okay, in Toyota Gosheim, they have got 10 master black belts in their company. So Toyota Gosheim is the sister concern of the Toyota. So they produce some of the parts required, plastic parts, the polymer parts required for Toyota companies. And the black belts, they operate under the master black belts to apply Six Sigma methodology to specific projects, and they primarily focus on the Six Sigma project execution. Green belts are the employees who take up the Six Sigma implementation along with their job responsibilities. They are called the green belts. Okay, they operate under the guidance of black belt and support them in achieving the overall results. Okay. The the levels of Six Sigma certification in India. Okay, you should know where you can get the Six Sigma certification. Okay, Six Sigma green belt certification and green black belt certification and master belt certification. Okay, as a Six Sigma training people are the we people where we are implementing Six Sigma, we should know the roles of these people. Okay, and also we should know where we get certified for this Six Sigma. Okay, so no matter where your business in the world, ASQ can deliver a training solutions right to your location. ASQ, okay. So the ASQ stands for American Society for Quality. It is a certification agency. Six Sigma Green Belt duration is 8 days. Six Sigma Black Belt duration is 15 days. The weekend Saturday Sunday classes they also conduct. Okay, at the Mumbai, Chennai, Bangalore, Mumbai, etc. The you have an option of remote learning also in the country worldwide. And ASQ South Asia and IIT Kharagpur have jointly developed an unique campus residential training programs on the Lean and Six Sigma programs at the IIT Kharagpur. The second is Indian Statistical Institute (ISI), which is there in the Bangalore. It is a government institutions offer training programs where you can get certified. Okay, they run 3 courses every year: green belts, black belts, master belts. And third, the Benchmark Six Sigma. It's another agency which certifies the Lean Six Sigma certification. But then you are aware of now you know what is supply chain, you know what is Lean practices, what is Six Sigma practices, and their goals. Okay, the Lean has to eliminate the waste and increase the process speed. The method used are lean concepts and principles. Genchi Gebatsu. It is called as go and see the workplace. Gemba. The Toyota practices. The Kaizen. Change for the better. Six Sigma. Goal is to reduce the variation to improve the performance on the CTQs. Methods. DMATV, DFSS, and other approach. Now, how these philosophies or the cutting edge technologies are being used in the supply chain. So you have the knowledge of all the concepts of supply chain, lean, Six Sigma, statistics, and everything, and also how these being used at the first stage. We cannot apply at the overall. Okay, we need to consider stage by stage implementation of this lean Six Sigma. Okay, consider the first stage of the supply chain, that is where the supplier and manufacturers are involved. So there is a information technology being used, that is EDI, electronic data interchange, and they use B2B business technology to integrate, okay, the both suppliers and manufacturers across the globe. Okay, and the manufacturers will place an order to the supplier. Okay, usually the manufacturers will place an order, electronic order to the suppliers, raw material suppliers. Okay, so the order specifies what quantity of the raw material to be supplied, what quality of the material to be supplied with respect to size, material, specification, etc. And also they specified the delivery schedules, that is on what date the orders have to be reached to the plant. Okay, so these are all the requirements of manufacturers or the suppliers of raw material. Then how to apply this Six Sigma at the stage one of the supply chain, that is called as a procurement process. This procurement process is one process. We need to discuss about the implementation Six Sigma at only the procurement process. Collect the data of the quantity of the material supplied with respect to the purchase order. That is, how many times the right quantity of the material ordered is being supplied. How many times there is a deviation with respect to the purchase order with respect to the quantity supplied by the vendors or the suppliers. Okay, so then calculate the sigma level. We are at sigma level 3, or we are at 4, or we are at 2. So assume that we are at the sigma level 3.6. Okay, then how to improve to this sigma level 4.4 sigma, how to improve from 4 sigma to 5 sigma, and how to improve from 5 sigma to 6 sigma. Okay, we need to analyze with respect to the quantity of material being supplied. In the same fashion, collect the data about the quality of the material supplied with respect to the purchase order of the manufacturer. How many times how much quantity of the right material is being supplied with the right quality, and what is the deviation of the quality with respect to size and specification. Then assess the level of Six Sigma. Assess the level of Sigma, not Six Sigma. Assess the level of Sigma and analyze, identify the factors. Okay, assume that we are at 3 Sigma level. What are the factors are hindering to the quality of the material? What are the factors are hindering the quantity of the material being supplied by the suppliers? That's why we are at the 3 Sigma level. Then how do we take this from 3 Sigma to the 4 Sigma? That is first target. Similarly, for the delivery schedules, okay, collect the data of the delivery dates of the schedules with respect to the purchase order. How many times the supplier has supplied the material at right time of the delivery specified purchase order? How many times there is a deviation about the schedule? Measure and rate the vendors with respect to the Sigma level. Okay, if the companies, some of the suppliers, if they are Sigma industry, they are practicing. And because of this commitment of the Six Sigma supply, for the raw material to the manufacturing plant, they are eligible to adopt the just-in-time practices. The Toyota industry, they don't keep any inventory in the stores. They are manufacturing around 150 Krista cars per day. Imagine, for every 2.57 minutes, one assembly of Krista is coming out of the assembly line. So measure, identify the factors, and what sigma level we are presently with respect to the purchase of the material, with respect to quantity, quality, delivery, and identify, improve, and then we can reach to the Six Sigma in one day. And apply this DMAC philosophy, which has been discussed for the procurement stage, continually improve to reach the Six Sigma. And it is not being achieved overnight. Imagine, it is being not achieved overnight. It takes years together. Okay, similarly apply for the manufacturing process. Okay, take the data for the planning and scheduling. Okay, whether we are adhered to the plan or not. If not, what are the deviations? Component manufacturing, sub-assembly process, final assembly process. Okay, collect the data with respect to all these manufacturing parameters. That is, we are at the sixth stage. We are implementing the Six Sigma in the second stage of the supply chain. First stage, we have applied Six Sigma concepts. We are improving. In the second stage, collect the data with respect to the all these parameters. Okay, whether the how much sub assemblies or the components or the finished assemblies are accepted and rejected, and calculate. Okay, and calculate the uh, uh, calculate the sigma level, calculate the sigma level, and try to improve those processes. What is hindering the process? Identify the factors, improve it using the DMAC methodology. Then DMAC for the manufacturing process and improve continually to reach Six Sigma and not being achieved over the overnight. It should be, we need to sweat our blood for years together. Okay. Then implementation of lean principles and this second stage, identify work in process, overproduction, production, rework, excess time, waiting time between the workstations, and bottlenecks in the process. So these are all the observation have to be made at the Gamba. That is nothing but the workplace. Okay, I keep visiting the Toyota Industries every year, 4 to 5 times. I'll be with the managers because we have got a good relationship, and the general managers are there in our board of studies. I keep going, they keep coming to our college department. We have a good relationship, and also we have a MOU with them. So in this context, I know all these cutting edge practices in Toyota Kirloskar. Okay, then apply the value stream mapping, just in time philosophy, 5S philosophy, vendor managed inventory, Kaizen, Kanban, Okake, all these cutting edge practices. Okay, hence the Toyota, okay, they are the leaders, they are the world class manufacturers in the world. Okay, then implementation of Six Sigma, similarly in the third stage. Okay, so the same way what we did in the first stage and second stage, the same philosophies, you need to identify the CTQs, okay, and consider the where you needed improvements. Okay, collect the factors, apply DMAC principles, and control it, and check your sigma level and try to improve day by day. Okay, so we can apply lean Six Sigma methodology everywhere. Okay, where we are interested to improve the process at higher level. The Toyota Kirloskar Private Limited Biddi, okay, they have used these Six Sigma concepts, so they are able to manufacture the products very in the faster rate. Around 10 to 15 years back, As I told you that we have a good relationship with since 20 years, okay, with the Toyota Kirloskar. Around 10 to 15 years back, the production rate of the Innova was 3.57 minutes. One Innova they used to produce. Okay, it is 15 to 20 years back. So now they are able to produce one Krista for 2.35 minutes. That is, for 2.35 minutes, one Krista comes out as a finished ready product from the assembly line. Okay, imagine 3.57 to 2.35 minutes, the reduction of 1 minute in the production of Krista. Okay, it took 15 years to reduce it from 3.5 to 2.35 minutes. It was possible only because of the implementation of these cutting edge technologies like Lean Six Sigma and supply chain just in time practices, and also they are implementing industry 4.0 concepts. Okay, this is one experience or the success story, and we can apply in our personal and professional life to improve ourselves. Even we can apply in the department, even we can apply in the college. For example, for NBA accreditation, quality level. NBA stands for assessment of the quality of the department. Okay, whether we need to accredit for the 3 years or 6 years. Okay, the 6 years it's very difficult to get accredited for 6 years. And NAC to get A plus plus is also very difficult. And also it can be applied for NIRF ranking. It is being recently announced. Okay, if you are at 76th rank, how to get 50th rank? Okay, they need to identify the factors, analyze factor, apply DMAC philosophy, Six Sigma philosophy, try to improve the rank, try to improve the quality level. Okay, I'll share one little my experience in implementing in education. Okay, when a new NBA guidelines came for outcome-based education, that is ABET. Okay, we are highly worried to apply for, because everything was new, the requirement was new, and they were new and they were challenging. Okay, I was the head of the department in 2010 and 2014. The management asked me to apply. I studied the NBA disclosure and applications and identified the CTQs and defined, measured, analyzed, improved, and controlled the department processes over a period of 2 to 3 years. And we are succeeded and we are applied. Okay, in the 2013. Okay, I struggled for 3 years. Okay, for by applying this DMAC philosophy for the new ABET system of accreditation, and we are succeeded to get 5 years of accreditation. Our industrial engineering and management was accredited for 5 years, and it is going to be closed this month. Okay, it is the second department and the second college in the Karnataka to get 5 years of accreditation. The first college was BMS. So, okay, so far no department has got 5 years of accreditation till now in the Karnataka. Okay, this is only possible because of the implementation of Six Sigma practices in the departments. So, you faculty members, try to improve yourself even in our daily life. Identify your issues or the problems, how to improve those. Okay, you can apply DMAC philosophy, Six Sigma philosophy. One or the other day, you'll be the best professors in the college or in the university. Okay, when you want to apply for that, you want to apply for your knowledge, what we learned today can be applied in your departments, applied in your college to improve the Six Sigma practices. Okay, another 5 minutes I'll take. So these are the implementation success stories. The Caterpillar, okay, it is called as a CAT in the world largest construction and mining equipment, and they implemented the Six Sigma methodology and philosophy, okay, in the year 2018, and they stand 65th place in the Fortune 500 companies list. Okay, and they used the philosophies of Lean Six Sigma, they use the philosophies of Lean Six Sigma in their business process improvement. Then the second industry, that is Honeywell International Corporation. Okay, so they applied the focuses on the lean concepts in the waste elimination, and also for the various reductions, okay, in the Six Sigma. Okay, and they applied both lean and Six Sigma. That's why I slightly changed my presentation. Why only on Six Sigma? Why should I not include lean concepts? Because lean and Six Sigma, they are the two legs for the supply chain. They are the two legs for the supply chain. So there is huge benefits, okay, for implementing these Six Sigma and lean practices in Honeywell. Okay, they raise their productivity to the greater height. And the General Electric, okay, they are also it is an American multinational company. Okay, the chief executives, CEO of the GE has implemented this Lean Six Sigma philosophy, and because of the implementation, they invested 300 million in the Six Sigma training. After that, they raised their productivity, and they gained the profit of margin of $100 million to the $200 million. Okay, and they are also the 18th largest firm in the Fortune 500 company. And also 3M company. Okay, they are the Minnesota mining and manufacturing. They're called the 3M company, US based company, an American multinational corporation. They involve the Six Sigma philosophy and also the lean philosophies, and they made $31.7 billion in total sales, and this company is being ranked as 97th in 2018 Fortune 500 companies. Okay, every year the whole world, okay, they assess the company performance and they put it in the list called as 500 Fortune companies. Okay, based on the best practices, and these are the some five pillars of the technology success, and they drive the industry performance. And these are all some of the Six Sigma companies across the globe. Okay, then this presentation will be shared to you by the coordinator of this workshop. Okay, with this sharing of my little knowledge and experience on this cutting edge and state of art technology, and my presentation. If you understand the basics of the lean, Six Sigma, and supply chain, is more than sufficient. And one of you to take up the if you one of you take up the projects, you understand the essence, the flavor of the lean and Six Sigma supply chain practices along with your students projects. Thank you very much. Any questions, please? Okay. Okay. Hmm. Supply chain software, there is a I2 technologies in the Bangalore, and it is the training. Okay, the trainings will be arranged for the, even you can refer your students who are interested in undergoing an ERP training or supply chain training. So there are I2 technologies and SAP lab. They conduct all these supply chain training programs. And nowadays the ERP training is nearly under we need to undergo a 6 months of training. Okay, it's not so easy to learn in 1 or 2 days. Okay, the Arena Sixth Sense, there is a simulation softwares where we can build small modules of ERP, and we can use it. And also there is a one more software in our lab. I'll let you know. Okay, I will send you the list of softwares available in the market, as well as their price, and as well as the students who are or the industry or the faculty, if they are interested in undergoing training programs. I will give the list of companies who give training for the students. Okay. And I specified the Six Sigma training or the black belt training. I specified some three institutes: Indian Institute and Six Sigma Institute and ASQ Institute. They provide the Six Sigma training programs. Okay. Hmm. Qualitative, quantitative. I gave an implementation of, say, for example, the procurement side in the supply chain. Okay. Usually, the supplier will specify what quantity is to be supplied, of what quality to be supplied. Quality means what? What will be the size? What will be the color? What will be the composition? Okay. What is the specification? What is the length, diameter, something like that? They specify in the purchase order. Okay. And also they specify the delivery schedule. Okay, these three parameters usually be there in the purchase order when the manufacturer or the materials manager places an order to the supplier. So the supplier, how he supplies the materials with respect to the quantity, how he supplies the quality of the material, and what will be the delivery schedules may not be on time sometimes may not be on time. So if it is on time, no problem. If it is off time, why? If the material quality is bad, which is being supplied by the supplier, why? He has supplied the bad quality. Why we have asked for 10 tons of raw material, he supplied 9 ton. Why? It is a deviation. So like this, we need to provide an orders of 1 million opportunity. If in 1 million purchase orders, if he is able to miss only 3.4 missed deliveries, missed quality, missed delivery schedule, missed delivery quantity, then it is Six Sigma procurement process. So if it is 20,000, 30,000, 2 lakh, then we are not at Six Sigma level. There are certain issues and the problems we need to analyze. As a supply chain manager, we need to identify what are the characteristics or the CTQs are affecting the procurement processes or the supply processes of the supplier. Then we need to brainstorm, discuss with the suppliers, call the supplier meeting, why they are supplying bad quality, why the late deliveries, the issues have to be solved. Then try to improve our business process of procurement. Like this, we can keep on implementing. We need to go to the Gamba, that is nothing but the shop floor, unless until we collect data, because it is a fact based. Okay, we need to collect data. Tell. Ah, why not? They let them decide what is their process. It is a process based, not an whole organization. I told you that identify, say for example, okay, we are getting defects in our component which are being manufactured in the MSME. Assume that they are manufacturing their shaft. These shafts are getting rejected. Assume that they are getting rejected. The some of the components are shafts are getting rejected. So they identify factors. Why? What are the rejection causes? What are the problems because of which our components which have been manufactured are rejecting? Is it because of the worker? Is it because of the machine? Is it because of the raw material defect? Okay, is it because of the defect in the measuring instrument? Identify what are making you to get rejected your MSME manufactured components. Okay, then brainstorm, discuss with the members, fellow members, include workers also, and also the engineers, the junior engineers, design engineers, production engineers. uh, Talk to them. These are all the issues. Make a presentation and identify the CTQs and how to improve that, how to improve the material properties, how to improve the manufacturing, how to improve the measuring instruments, get it calibrated accurately. So, like this, we need to identify and figure out and can be applied for a component based, or sub-assembly based or assembly based. Okay, it can be i- implemented even for small scale also. Define your process where we need to improve. It can be applied anywhere. Even I told you that in personal life. Okay, I have got certain weaknesses in the department. I'm highly arrogant. Okay, I don't have a patience to tolerate, listen to our subordinates as the head of the department, and how to change, how to improve. Okay, so like this, we need to identify the process and it can be implemented by anybody, anywhere, whether it's MSME or small scale industries or big industries. Big industries, more processes, small industries, small process. That is not a few processes. Okay, any doubts? Thank you very much, participants. If you have got any doubts, okay, my mail ID will be dropped to you, and my mobile number also will be dropped to you, and you can directly mail to me to ask any clarification. Thank you very much for patient hearing my presentation, and I ask once again a sorry for the interruptions in between the presentation, which is caused by the down in the server in the college. Very sorry. Thank you very much. Thank you.